Hey guys, in this video, PS, you've made it, last video of the day, congratulations. Okay, so in this video, what we're gonna do is we're gonna talk about combining variables. So we're moving from transforming, which is where we had one distribution, and we transformed that distribution. For example, we had the number of credits people took at El Dorado Community College, and then we multiplied it by 50 and then added 100 to figure out the total cost of tuition at El Dorado Community College, right? Okay. Now what we're going to do is we're going to move over to something called combining distributions. So we're going from singular to plural, combining those together, finding out averages, finding out standard deviations. Let's get started. The amount of money spent at books in the fall semester for a randomly selected student at El Dorado Community College is let B equal that, sorry. Suppose that mu of B is equal to 153 and standard deviation of B is equal to 32. So what I'm going to do right now is I am just going to put a rectangle around this, just noting this. Hey, we have one mean and we also have another standard deviation. Okay, and then so we said, recall that C equals the overall cost of tuition and fees for a randomly selected full-time student at El Dorado Community College. This is what we found earlier in the last video. Okay. Okay, so now what we have is we have the average spent on books, right? And then we also have the overall cost for tuition and fees for a full-time student at El Dorado Community College. Now what we want to do is we want to find the mean and standard deviation of the cost of tuition, fees, and books for a randomly selected student at El Dorado Community College. Whenever you are finding an average of two or more distributions, it's very straightforward. You're just going to add those together, or you may subtract them, okay? You just have to look for keywords that will tell you if you're adding or if you're subtracting. So in this case, it just flat out gives you an addition sign, okay? But you can also think, okay, wait, I want to know the total cost of tuition, fees, well, that's this, and books. I'm going to combine that together. That's adding, okay? That's not subtracting. You don't see anything about a difference, okay, right? So let's just go ahead and do that right now. We would take mu of B plus mu of C. And that is going to be 153 plus 832.50. And that gives us a combined average of, what is that, $985.50. Okay, so what would I want to see on a test, right? Obviously, I want to see the correct answer right here, but I also need to see this work. Okay, very straightforward. What's not so straightforward, or not necessarily not so straightforward, but what's something that you have to actually memorize because it is not on the formula sheet, is the standard deviation. So if I want to find the standard deviation for the total cost of tuition, fees, and books, I'm combining these together. Now you would think that you would just add these together, and that is incorrect. But there is a formula for it, okay? But before I can even show you the formula, okay, to figure out the combined standard deviation, I need to talk to you about something called a condition. In statistics, we have these conditions, and we have to check these conditions in order to use a formula or to run a certain test, okay? For example, many years ago when I was your guys' age, right? If I wanted to go to a movie, a rated R movie, okay? I lived in this area, so I'd go to the Plymouth Man movie theater, right? And if the movie was rated R, there would be someone standing outside the door, and he would check my ID to make sure I was 17. That was a condition. I had to be 17 in order, right? In order to go into the movie theater and watch that movie. Now, what if I didn't have my ID? He could assume that I was 17 and let me in still. And sometimes we do have to make assumptions in AP statistics, but in this one, we can actually just check that condition. And let's go for that. So what is the condition? When we find the standard deviation of combined variables, we check for the condition of independence. So we have to say that these two variables are independent of each other in context. So what are my two variables that I'm looking at? I'm looking at the amount spent on books, and I'm looking for the overall cost for tuition and fees, okay? And get rid of that because it looks sloppy. That's okay. Okay, so all I need to do, you guys, is I just have to say books and tuition and fees are independent of each other. There's no math involved. You literally just check that off. Yes, check. We're okay now to use the formula. And what formula is that? It is this formula right here, okay? We're gonna take the standard deviation of one of the variables squared, that's the variance, plus the standard deviation of the other variables squared, again, that's the variance, add them together, so we add those variances together, and then we take the square roots of them. Now, it's important to note, guys, look, whether we are adding the distribution together or subtracting the distribution, we always add the variances, those standard deviation squareds, and then take the square root when we're figuring out the standard deviation. Always, 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 okay? So let's go ahead and do that now. We know that the standard deviation for books is 32. So I'm going to take the square root of 32 squared plus the standard deviation for tuition and fees is 103. So I'm going to take 103 squared. And then I'm going to find the square root of that. So I'm going to grab my calculator out right now because I can't do that one in my head. I'm going to take 32 squared plus 103 squared. Okay, I'm going to enter, and then I'm going to take the square root of that. And you could type it in all at once as well. I just didn't. Okay, so we have 107.8564. 8564. There you go. Combining variables, right? Add or subtract, whatever you're doing for the means. Standard deviation, check the condition. You will get docked on a test if you don't do that, okay? Show me your work in the formula. Give me the correct answer there now. Now, I wish I could say it was always this easy. It gets just a tiny bit more difficult. And then that's when we're talking about continuous variables with a normal distribution, okay? So we have weights of a certain apple. That's a continuous variable. It is not a discrete variable. It's not a countable thing, okay? Suppose that the weights of a certain variety of apples have weights that are approximately normally distributed. Ding, ding, ding. Whenever you see this word, I want you to right away think, I'm going to be using a Z-score. I'm going to need ZOMS. ZOMS is equal to our observation minus our mean divided by our standard deviation, okay? So we have weights that are approximately normally distributed with a mean of 9 ounces and a standard deviation of 1.5 ounces, okay? If bags of apples are filled by randomly selecting 12 apples, what is the probability the sum of the weights of the 12 apples is less than 100 ounces? Okay, what's going on right now, you guys, is we're going from the weight of an apple. An apple is 9 ounces, okay? So, we're going from singular to plural to 12 apples, okay? So what am I going to do? I am combining variables here. I do want to find the probability. When we're finding probability with normal distribution, that's a Z-score, go into the table. I'm actually going to show you how to actually use the calculator today to do that. But we're going from singular to plural, okay? First thing we want to do is we want to find our new mean. Okay, so step 1 over here. Well, what am I combining? I'm not combining like an X and a Y, like books and tuition. I'm combining the same variable, apple plus apple plus apple. I'm going to say apple is X. So what am I doing? I'm literally saying X plus X plus X plus X. I'm doing that 12 times. Well, I could just go ahead and do 9 plus 9, right? Because an average apple now is 9 ounces. It tells us that right there. But we're dealing now with a distribution that is not talking about 1 apple. It's talking about 12 apples. That's why when we draw our curve, guys, we're not going to put 9 there because this distribution is about the bag of the apple, okay? The bag of the apple, and that's 12 apples. So again, I'm finding the mean of this distribution. So it's not 9. It's going to be 9 plus 9 plus 9. And I'm going to do that 12 times. Well, it's much easier just to take 12 times 9, okay? And figure out the mean that way. I just wanted you to get used to thinking because I didn't want you to think it was a transformation, right? I'm literally taking an apple plus an apple plus an apple 12 times. I'm combining 12 apples together. So it's just easier to do 12 times 9. Let's do 12 times 9 right now. I'm sure some of you could quickly do it in your head. I'm sorry. I just don't want to make a mistake on video by doing math too fast. 108 ounces. Some of you have already noticed me do that already. Okay, there we go. Next, what we need to do is we need to find the standard deviation, okay? Now, again, we're combining variables. We're going from a singular to plural, 12 apples. When we find a standard deviation, we cannot forget to check for independence. So we're just gonna say weights of apples are independent of each other, okay? Then what we can do to find that standard deviation, guys, right, is I take the standard deviation of one of the apples and I square it, plus the standard deviation of another apple and square it. And I need to do this again 12 times. Why? Because I have 12 apples that I'm combining together. So instead of doing it 12 times, I am just going to take the square root of 1.5 squared times 12. Let's put that in our calculator now. Square root 1.5, right? Squared times 12. And that gives me 5.1962. 5.1962. Okay, so we have our mean, we have our standard deviation, we have this normally distributed word, right? We have this probability word. That means we're going to be finding a z-score. So I'm going to draw my curve, guys. We know we have 108 right here. We have a standard deviation of 5.1962. I'm trying to figure out what is the probability that the sum of their weights, so right now the average weight of 12 apples is about 108 ounces, okay? We want to know what is the probability that if we had a bag that it's going to be less than 100 ounces. That's my observation right here. Okay, so I'm going to find my z now. My z-score for this distribution would be 100 observation minus the mean divided by that standard deviation. Let's do that now. Find that z-score. Okay, I'm going to go to my calculator. 100 minus 108. I do know what that is, but that's okay. We'll just hit enter. Divided by 5.1962. And that gives us negative 1.54. With the z-score, you can round to the nearest hundredth. I think I said negative 1.54. Let me just double check. I don't want to make a mistake. There we go. Very good. And now once we have that z-score, I know I told you I'd show you how to use the calculator, but I think I'm going to do that another day just to save you time. I don't want to teach you anything new from here, new regarding that table. You guys are used to that table, so let's go to that table. We have a z-score of negative 1.54. Negative 1.5 is right here. 4, whoops, right here. 4 is right here. That gives us 0.0618. And you can leave it as that proportion there. Okay, so that's that probability of getting a bag that is less than 100 ounces. Okay, take a deep breath. I have one more to show you. It's an important one though. I know you've been doing a lot and you've been watching a lot of videos today, so hang in there. Okay, long one here. Again, I'd encourage you to print this off if you can. Definitely don't like write this all down in your notebook. I just think that's well, you can, but it's a lot of work. I think if you just kind of summarize it in your own words, that this is a problem about a local supermarket. They have pints of strawberries on special. The strawberries are packed as either medium or large. Since you love strawberries, you decide to pay extra money for a container of large ones. Well, your frugal friend decides to purchase the medium-sized package. On the way home from the market, you both decide to eat some of the fruit you bought and each take a strawberry from your respective containers. Surprised to find that your friend's strawberry is larger than yours, you decide to gather some data, being the good statistician you are. Your supermarket buys its produce from a large distribution center where large strawberries have a mean weight of 6.1. Okay, so if you're gonna write something down, this is what I would write down, right? We have large strawberries have a mean of 6.1 centimeters with a standard deviation of 1.2. And medium strawberries have a mean height of 4.8 centimeters and a standard deviation of 1.6. Further, the heights of the strawberries are approximately normally distributed. Again, we're dealing with a continuous random variable. When you see normal distribution, think ZOMs. Given this information, if a person were to select from strawberries sold at the distribution center, a random strawberry classified as large and Given this information, if a person were to select from strawberries sold at the distribution center, a random strawberry classified as large and a random one classified as medium, so they're picking two strawberries now, what is the probability that the medium strawberry will have a greater height than the large one? Okay. This is a hard one for people, okay? But what's happening now is, how do I know if one has a bigger height than the other? Well, yes, we could just look at it and say, well, this one's bigger than the other one, okay? But it is saying, what is the probability that the medium strawberry will have a greater height than the large one? Which means we're gonna have to find a Z-score. Why? Because we're dealing with a normal distribution, okay? We're dealing with a normal distribution. Well, again, how do I know that one is going to be bigger than the other? What am I going to do? I'm going to subtract. That's how I'm going to prove it. Okay, I'm going to prove it. Step one, we're going to find our new mean. Think, are we using addition or subtraction? So we just talked about, okay, how am I going to prove that one is bigger than the other? We're going to subtract it. We're combining this distribution right now, and we're going to talk about this. And I'm going to set it up like this. I'm going to say that this distribution is a distribution that describes large strawberries minus medium strawberries. Could I have done it the other way around? I sure could have. Now, some of you are going to want to just put a large curve and a medium curve, and we never do that, okay? We never do this. So this problem definitely takes some that and some practice, okay? So large minus medium. The next thing that we want to do is we want to find, well, what would be the mean, okay, of this distribution? Well, the mean of a large strawberry is 6.1, and the mean of a medium strawberry is 4.8. So I'm going to take 6.1 minus 4.8. And that's going to describe, right, our mean. So 6.1 minus 4.8, I can do that in my head. But you guys know me with my fast work. I've made mistakes on that before. Yeah, and you've caught me, and it's quite embarrassing. Okay, 1.3. Okay, so what this is saying, guys, what this means, just so you know, you understand what it means. On average, a large strawberry is going to be 1.3 centimeters taller than a medium strawberry. Right? On average, a large strawberry minus a medium strawberry is going to be on average 1.3 centimeters larger. Now let's talk about the standard deviation. We do need to check for independence. So before we can find this standard deviation, we do need to say heights of strawberries are independent of each other. Okay? Let's go ahead now. Let's find that standard deviation. All right, where are we? We have the height of a large strawberries. That standard deviation is 1.2. So we take 1.2 squared. Plus, again, remember, it's always plus, whether we're adding or subtracting. The standard deviation for a medium one, it looks like it's 1.6 centimeters. So 1.6 centimeters squared. And so we have the standard deviation there, which is equal to 2, which is a nice number there. Now, this is the part that requires a little more thought from some people. Remember, okay, we're asking at what point, okay, so well, let's rewind. What is the probability that the medium strawberry will have a greater height than a large one? This is a number line right here, okay? We're saying on average, a large strawberry will be 1.3 centimeters taller than a medium one. If I would move to the right of this graph, that strawberry, that large strawberry is just getting more and more, or it's getting taller and taller. The difference between the two is getting greater, right? So you could say like, this is 2, if I had an observation here. This, if I took 2 strawberries and that observation was, and we found the difference, excuse me. So if I took 2 strawberries and I found the difference, we know the average is 1.3. But if I literally was measuring different strawberries and just seeing what the differences were, I could mark it anywhere on this number line. Over here, there's going to be a really big difference. Over here, it's going to be bigger than the average. Over here, it's starting to be not as big a difference. We're wondering where on the number line is the medium strawberry going to be bigger than the large strawberry? And on your number line, guys, that's going to be anywhere where my observation is less than 0. Because at 0, what am I saying? If I take 2 strawberries and I subtract their heights and I get 0, that means they're the same. But anywhere to the left of 0 is a negative number, okay? Is a negative number. If I get a negative number, that means the medium strawberry is bigger than the large, right? Because if this is smaller, small minus a smaller number minus a bigger number is going to give us a negative number. So my observation is 0 here. If you're like, whoa, this makes me really nervous, it's okay. It's okay. We're going to do another one in class together. We're going to do a partner problem. You'll get practice with this. Come to my office hours. I can try to explain it differently as well. Okay. But oftentimes when you have 2 distributions and it says at what point is one bigger than the other, you're looking at an observation of 0. Okay. So let's go our z-score. We have z is equal to 0 minus 1.3 divided by 2. Go to my calculator here. Negative 1.3 divided by 2. That gives us negative 0.65. Okay, I'm going to go to my table. Negative 0.65. So 0.2578. And that's our proportion there. That's our probability. All right, there we go, guys. Awesome. Thank you so much for your patience.